This is an introductory tutorial for puppeteering Metahuman with the MediaPipe4U plugin, starting with creating a project. Before starting the tutorial, you need to prepare the following software: UnrealEngine 5.0 or 5.1, version 5.1 is recommended. Writer or Visual Studio 2019-2020 seconds. Quixel Bridge has been installed in UnrealEngine, a character made in Metahuman Creator. Now, let's launch the Unreal Engine. Create a new blank project, a UC++ project. Of course, you can also use blueprints as project type. It is recommended to use the C++ type because it can use both blueprints and C++ code. I named the project Metahuman Import. It takes a little time to create a project. This free time, we prepare some other things. First, search for Metahuman document in your browser and open the official Metahuman document. Then search MediaPipe4U demo. This is my MediaPipe4U plug-in demo project page. You can download it to learn more usage of MediaPipe4U. Here we use the scripts in the demo project. After the project is created, Unreal Engine will automatically start. This is the new project directory. Create a new script file in this directory to clean up the project. Of course, you can also clean it up manually. Just create a new text file and change the file extension to BAT. Open it with a text editor. I am used to using Notepad++. You can use the Windows built-in Notepad. Find the clean project script file in the demo project. Copy its content to the newly created script file, and you only need to run this BAT file if you need to clean the project in the future. Create a new plugins folder in the project folder. To create a second script, find the plugins folder in the demo project and copy the content of the make link script file. Create the script file in the plugins folder in your project. Paste the copied content into this script file. The purpose of this script is to create a folder link for the MediaPipe4U plugin, so that when you use the MediaPipe4U plugin in multiple projects, you only need to store one copy on the disk, and then you can link to multiple projects. The file path in this script should be changed to the directory saved after decompressing the MediaPipe4U plugin you downloaded. This is my directory. You change to yours. Now, double-click to execute the script and create a link to the plugin folder. By the way, because you need to use Writer to compile, so close the living code of the following projects. In fact, I recommend never using living code because it has a lot of bugs. Let's continue with the previous steps and create a link to the plugin directory. After executing the script, the directory is linked. you can open any directory to check whether the link is correct. Now, go back to the project root and execute the first script we created to clean the project. After cleaning, use UnrealEngine to generate a versus file. Click the right mouse button on the project file and click Generate Visual Studio File. This process will take a few seconds. Please be patient. After the generation is complete, use Versus or Writer to open the Salon file and start compiling the project. If the living code of the engine has not been closed before, an error will occur when compiling, and the living code can only be closed through the editor or run the editor to let it close automatically after an error. This is a long process. Writer inherits the fine tradition of IDEA. Each project needs to rebuild the index. It uses the Lucene inverted index, and the creation process is very slow. When the wait is over, the C++ project is ready. Right-click the project in the project browser window, and then click Build Solution, which is similar with Visual Studio. This process takes about 30 seconds, after which you will see a prompt that the build is successful. The following operations no longer require a C++ development environment, and you can close Writer or Visual Studio. Double-click the project file to open UnrealEngine. The engine has prompted to find a new plugin. Open the plugin settings, and you will see that the plugins of MediaPipe4U have been enabled. This is a map created by the template of the blank project. We start here and complete the Metahuman driver step by step. The first thing is to import the Metahuman character. Open Bridge, find your Metahuman, click the Import button. This process is pretty fast. I imported my character in about 20 seconds. Because it is a blank project template, there are few plugins. UnrealEngine will prompt you to enable some plugins. Just click Enable. In the content browser, you can already see that Metahuman has been imported, and now it prompts that the engine needs to be restarted. Click Restart. I'll check Metahuman's blueprint. The engine starts to automatically compile shader. You can see that several functions in the blueprint are obsoleted, probably because my Metahuman plug-in version is not the latest, but we can manually fix these warnings. Compile again, fix the next one. Of course, it's just a warning, you can ignore it. I'm just here to demonstrate how to fix it casually. Now, the warning is no longer visible. Well, this is all the preparations. Let us start using MediaPipe4U. I created a folder to store the assets made in the tutorial. Because it is just an introductory tutorial, I put it in a folder. This is not the best practice. It is also a good working habit to keep the folder organized. Remember to save it at any time to prevent accidental crash of UE and loss of work. Let's create the first blueprint first, which is a character blueprint to make a motion capture character. At this time, I recommend you to read the official Metahuman documentation. Of course, its documentation uses the retarget method. I use the direct drive method here. If you can't use redirection, don't use it. After reading this chapter, you will know how to make a runtime-driven character. First, copy some skeletal meshes and hair from Metahuman's blueprint. Note that you don't need to copy the body. Move them under the mesh. Keep the hair hierarchy. The hair components are all under the face mesh. Go back to the Metahuman blueprint and check that the hierarchy is correct. Find the mesh asset for the body mesh in the Metahuman blueprint and select it in the content browser. Go back to your character blueprint and set the body's mesh asset to the mesh skeletal mesh component. Now, you can see a completed character in viewport. Adjust the character for capsule collider. Make the orientation consistent with the direction of the arrow component. Compile the character blueprint. Now you need to copy the constructor in the Metahuman blueprint. As you can see, the constructor calls the function enableMasterPose, so first, copy this function. This process corresponds to this part of the document. Double-click to open the enableMasterPose node, and you will see the function content. We can copy directly from the list of functions on the left. Ctrl-V paste into the function list of the character blueprint. Click Compile and find an error. Because body is mesh in our character blueprint, replace it. Compile again, successfully, and now you can copy the constructor. Note that the constructor only copies the first 3 enableMasterPose nodes and their pins. Open the constructor in the character blueprint and paste it in. At this point, a Metahuman character blueprint is completed. I save the current level. Next, let's make the animation blueprint. Locate Metahuman's body skeletal mesh asset in the content browser. Right-click to create a new animation blueprint. Of course, you can directly create a new animation blueprint and then select the body asset. Open this animation blueprint, adjust the base class in the class settings. MediaPipe4U must use MediaPipe animation instance as the base class. Add the pose calculation node of MediaPipe4U. Do not add other nodes. First, ensure that a node can work correctly. Now we create an actor blueprint to mount the runtime components of MediaPipe4U. This actor is named BP MediaPipe. To run MediaPipe4U's camera motion capture, only one MediaPipe holistic component is required. If you also need to capture motion from videos or pictures, you need other components. For details, please read the MediaPipe4U documentation. Next, let's specify the animation blueprint for the character's mesh skeletal mesh component. Drag character into the map. Adjust to the right position. Drag in the MediaPipe components actor. I create a folder in the outline to organize the structure. Try running it and checking the logs. There should be no errors in the logs at this point. You will also see the bone mapping table in the log, indicating that there is no problem with the initialization of MediaPipe4U. If you use a custom bone rig, you should check the contents of this mapping table for joint mapping errors or omissions. Next, let's turn on the camera and start real motion capture. I open the camera and begin play event of MediaPipe components actor. Just call the start camera function of the MediaPipe holistic component. At the same time, for the convenience of demonstration, I turned on the mouse pointer, and UE captures the mouse by default. Aligning blueprint nodes is a lot of work, which is why I don't like blueprints and prefer to use C++ directly. Now, run, and the animation will start. When driving Metahuman, when you zoom out the camera, you will find that MediaPipe4U produces an error. This is because Metahuman's LOD will delete bones. Currently, MediaPipe4U does not support LOD. There are two solutions. Use ARKit to redirect animation or turn off LOD. Here we turn off LOD as a teaching video. Let's go back to the source to let everyone know why these errors occur. Find the body asset of Metahuman. In the LOD settings of the body asset, you can see the LOD settings asset. Open this asset and you can see the source of the problem. In the LOD list, there is a configuration to delete joint bones in the following LOD configuration. Due to the skeleton change, the bone index changes, causing a MediaPipe4U error. Here, we set the number of LODs to 1, then click Apply, and save the asset at the same time. Run it again. No matter how you move the mirror, there will be no more errors. However, you will find that the legs of the character do not move. This is because I am sitting in front of the camera, and the camera cannot see my thighs, so the thigh-to-foot score is very low when MediaPipe calculates. You can adjust the score threshold if you want the legs to move even with the predicted pose. Set the scoring threshold to 0, so the joint will be driven no matter whether it is visible in the camera view or not. Run to see the effect. The legs are also moving. For the convenience of demonstration, here I set the animation mode to the upper body so that the lower body is still locked. Run again, you will find that the lower body will not move. Next, add the other two key nodes of MediaPipe4U in the animation blueprint. Hand solve node, used to calculate finger. Location solve node, used to calculate character location. Note that grounding is enabled by default on the location node, which allows your character's feet to stick to the ground. You will find that the character is suspended in the air. This is because the ray tracking of grounding is not configured correctly. To give you an idea of how it works, let's enable debug draw on the animation blueprint. Also enable debug draw on the location solve node. This will draw the ray tracking lines. Run it, and you can see the lines and boxes drawn for ray tracking. For how to read these information, please refer to the Position Node chapter in the documentation of MediaPipe4U. Next, let me teach you how to use grounding correctly. First, open the project settings and find the collision menu on the left. Click on the collision menu to add a collision channel. I named this channel grounding and set the default response to ignore. Place a panel mesh as the ground, and the panel will come with a simple collider. Find the collision settings of this panel, adjust the preset to custom, and let it block the grounded collision channel we created. Find the ground solver settings in the location solve node and select our newly created grounded collision channel. Run it again and find that grounding is working properly. For the convenience of demonstration, I will not let the character move here because I am sitting in front of the camera. In addition to locking the movement of the 3 axes, you can also set the solve location property to false on the animation blueprint. So far, the tutorial of the Metahuman motion capture part is over. For more usage, please read the MediaPipe4U documentation. Next, we start to enter the face capture part. Before starting, I still recommend you to read Metahuman's official documentation on the live link part. Face capture, mainly using the face skeletal mesh component of Metahuman, Epic has already produced a live link animation blueprint. Let's first look at the animation blueprint used by the face skeletal mesh component. In fact, this blueprint is very simple. Two variables are exposed on the blueprint. One is used to control the subject name of live link, and the other is used to control whether to drive the head rotation. So, the first step we have to do is to define two variables so that we can pass values from the outside to the face animation blueprint. You only need to get the animation blueprint on the face, set the variables on the face animation blueprint, and link the pins of the set to the variables on the character. Here I set the category of these two variables on character as live link so that we can search for them on character. Finally, don't forget to make the variables visible. You should now see the variable you just defined in the character details pane. Next, find the MediaPipe facelink actor in MediaPipe4U and put it into the scene. On the Details panel of the MediaPipe facelink, you can see a live-link subject name property. This is the subject that MediaPipe4U sends live-link data by default. Fill it in the subject variable on character. The default is MediaPipe4U. At this point, you can start using MediaPipe4U for face capture. The face expression is driven, although the effect is not good enough, but with the update of the training model, its effect should be better and better. There may be some warnings here. This is because we have not drawn the video image, so the image queue has full. In fact, if you display the video image, you will not have this problem. We can also set the display mode to RAW to eliminate this question. You will see that when the expression capture starts, the eyes of the characters are half closed. This is because each face has a different eye size or glasses, and the BS benchmark is different. We can use the calibration function to correct it. MediaPipe4U provides a calibration button in the editor. You can also calibrate in the blueprint. Please read the MediaPipe4U documentation for detailed usage. At this point, if you open the Live Link window of UnrealEngine, you can also see the live link source information of MediaPipe4U. You do not need to manually add or delete source. It will follow the start or stop of MediaPipe4U, automatically add and delete. This video was recorded in the middle of the night, and my camera was poorly lit, so the characters were shaking a lot. After reading the tutorial, you can already drive Metahuman through these steps, and it's a cool thing. Thanks for watching.